The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, let's get started here with problem number 7. And this is from section, click it again. There we go, 11.4, number 7. Complete the table of values. So if x is 81, what would f of x be? So if we have f of x equals log base 9, that's supposed to be a 9. That looks like a G, my bad. Okay. Of x. So then f of 81 would be log base 9 of 81. Well, log base 9 of 81 equals some unknown quantity, we'll call it box. If I take this logarithmic equation and I write it as an exponential equation, it would be 9 to the box power equals 81. But 81 could be written as 9 squared. Recall that because logs are one-to-one functions, if as well as exponential equations are one-to-one functions, that because I've got 9 to some power equals 9 squared, the unknown power equals 2. So the answer is positive 2. Okay, any questions about that example? Now let's take a look at the second part, which says f of 1 over 81, which would be log base 9 of 1 over 81. And log base 9 of 1 over 81 equals box. So 9 to the box power equals 1 over 81. But 1 over 81 is 1 over 9 squared. And 1 over 9 squared is 9 to the negative 2 power. So therefore, the box equals negative 2. All right with that? I'll take that as a yes. Okay, we're going on and taking a look at problem number 8. This is still in section 11.4, number 8. It says complete the table of values when possible. F of x equals log base 2 of x. And then it has input values of -2, 0, 1/8, square root of 2, and 2 to the 9th power. And it's a multiple choice. We need to pick which one is correct. And they all have the same inputs on the left. So let's just go ahead and complete the table. So input, output, -2. When the input is -2, we'd be taking log, so we'd have f of -2 equals log base 2 of -2. Recall that you can't take the log of a negative number, so this is going to have no output. Likewise, you can't take the log of 0, so this is going to have no output. So we've got 1/8 and the square root of 2 and 2 to the 9th power. Well, f of 1/8 is log base 2 of 1/8. And log base 2 of 1/8 equals some unknown box. Okay. Changing it to an exponential equation, 2 to the box equals 1/8. 2 to the box equals 1 over 2 cubed. 2 to the box equals 2 to the -3 power. So the box is -3. Okay. So we already know that the answers are none, none, and -3. It could still be either of these two. So we got to keep going. You see what I'm saying? In other words, we can eliminate this one. We can eliminate this one, and we can eliminate that one. So it's got to be one of these two. Well, let's see, square root of 2. F of the square root of 2 equals log base 2 of the square root of 2. Log base 2 of the square root of 2 equals box. So 2 to the box equals the square root of 2. 2 to the box equals 2 to the 1/2 power, right? Square root, 1/2 power. So the box equals 1/2. Well, so far, I haven't done the last value, but the only one that matches the first 4 has got to be this one. Okay. Oh, wait a minute. Wait a minute. I did that wrong. It's got to be. It's got to be this one. Yeah. Okay. None, negative 3. You know what? Let's do the last value. Let's do the 2 to the 9th power. So F of 2 to the 9th power equals log base 2 of 2 to the 9th power. Log base 2 of 2 to the 9th power equals box. So 2 to the box equals 2 to the 9th. The box equals 9. Okay. So it's got to be this one, because that's the one that matches all of those values. All righty. Number 9 is next. 7.4, number 9, fill in the blank. So log of x would be log base 10 of x. Log base 7 of 7x would be, well, let's see here. Log base 7 of 7x equals some unknown. Oh, that's not 7x, it's 7 to the x power. Okay. Details here, right? Okay. So got to get that written correctly. 7 to the x power. So that's equal to box. Change that to exponential equation. We get that. So the box equals x. So 9 part B would be x. Okay. That takes us down to 27. So 11.4, number 27. Solve for x. Log base 5 of 625 equals x. Changing this to an exponential equation, we'd have 5 to the x power equals 625. But 625 is 5 times 125, or 5 times 5 times 25, or 5 times 5 times 5 times 5. So 5 to the 4th power. So x is 4. Number 30. Solve for x. Log base x of 0.01 equals -2. So we've got, if we change this to exponential form, we've got x to the -2 power equals 0.01. Okay. Now, we need to solve for x. One of the ways we could do this is we could raise both sides to the -1/2 power. Why would that give us x? Because here, a power raised to a power, -2 times -1/2 would be 1. So this would be x equals 0.01 to the -1/2 power. Okay. Now, that's the same thing as 1 over 0.01 to the 1/2 power. Right? Well, let's see. That would be 1 over. What's the square root of 0.01? I'm going to use my calculator. Let's see here. The square root, oops, if I turn it on first, the square root of 0.01 is 0.1. What's 1 divided by 0.1? That's 10. I know that was kind of a long problem, wasn't it? So your answer there is 10. 33. Solve for x. Log base 121 of x equals 3/2. So we get 121 to the 3/2 power equals x. Well, that's 121 to the 1/2 power cubed, which is 11 cubed. And 11 cubed, 11 cubed is 1,331. And finally, number 42. Evaluate the logarithmic expression, log base 729 of 3. Well, that's equal to box. 729 to the box power equals 3. Well, 729, I believe, is divisible by 3. So 729, let's see here, that's 3 times. 729 divided by 3 is 243, which is 3 times 3 times 81, which is 3 times 3 times 9 times 9, which is 3 times 3 times 3 times 3 times 3 times 3, which is 3 to the 6th power. So we've got 3 to the 6th power to the box equals 3. But a power raised to a power, you'd multiply the exponents. So 3 to the 6 raised to the box is 3 to the 6th box equals 3. And that's an implied 3 to the 1 power. So 6 box equals 1. Box equals 1/6. Okay. And there you have it, folks. So with that, we're going on to the next section. So let me change screens, and I'm going to get rid of that and that. Give me just a minute here to get things set up. And let's see, okay. So in this next section, we're going to look at another common base. We've talked about how log base 10 is written as log because math people, whenever there was a shortcut they can make, they take it. So if there's no base written, it's base 10. There's another number besides 10 that is used a lot dealing with exponential and logarithmic functions. And that is the irrational number e. Now, because it's a letter that represents the number, we tend to think of it as a variable, but it's not a variable. Let's go back to another irrational number. Pi, we say, is approximately 3.14159, and then it just keeps going on and on and on. So we tend to say pi is approximately 3.14. That's not exact. If we wanted exact, we write it as pi. If we wanted approximation, we use 3.14, okay? E is approximately 2.71828, okay? So it's approximately, we'll say 2.72, or maybe even 2.7-ish, all right? What is E? Well, E is used when you have something that is compounding or growing continuously. Think back to the compound interest formula. A equals P times 1 plus R over K to the KT power, where K is the number of compoundings, all right? If it's once a year, annually, K is 1. Semi-annually, K is 2. Quarterly, K is 4. Monthly, K is 12. Daily, K is 365. What if K is just continuously growing. Well, then we approach the number e, which again is approximately 2.7. And this is used so much that when we want log base e, they use a notation ln, standing for natural log. If you look on your scientific calculator, right below the button that says log, there's another button that says ln, which is natural log or log base e. You should also see that the second function of that is e to the x power. All right. Anyway, now, so e is roughly 2.7. What we're going to do next is we're going to take a look at the graph of f of x equals e to the x. So give me just another minute here to switch things around. Let's see here. Here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1. Okay. So can you see the screen that has f of x equals 2 to the x graphed, and then there's a, in red, it has an x and a y?
Yes.
Okay, great, thanks. All right, so what we're going to do now is we're going to graph f of x equals e to the x. Since e is approximately 2.7, the graph of f of x equals e to the x would actually lie between 2 to the x and 3 to the x. But what I'm going to do is just go through and get the values using the calculator, all right? And I'm going to round them off here when it, let's see here. So f of -3 would be e to the -3 power. So on my calculator, remember I talked about how the second function of the ln natural log button was e to the x. So I'm going to go second ln, so second, and then ln, and then I get this e to the, okay, I'm going to put -3 in there, close it up and push equals. All right, I get 0.0497. I'm going to round that off and make it 0.05. Okay, so I'll round it off to the 100th place. Then I'm going to find f of -2. Okay, so same thing. I get 0.135, so we'll make that 0.14, again rounding off to the 100th place. F of -1 is what, 0.367, so 0.37. And then let's see here, f of 0, e to the 0 power would be 1. E to the 1 power would be approximately 2.7-ish. We'll say 2.72. F of 2, e squared, comes out to be 7.389. So we'll say what, 7.39. And then e to the 3rd power is 20.085 or 20.09. Now, so I kind of rounded those to the nearest 100th. Again, I'm not going to be able to graph it that accurately anyway, but I just want you to see what it would look like. So at -3, we're down here at 0.05, and then -2, we're up to 0.14. And then we're up to about a third, a little more than that, and then 1. When x is 1, y is 2.72. When x is 2, y is 7. Let's see here, 7.39. And then from there, it goes off the graph. So we've got this picture that looks like that. All right. Any questions about that? Okay, now, as with the other functions that we graphed, if we take, let's say, f of x equals e to the x plus 1, it's going to take this red graph and shift it up 1 unit. E to the x minus 2, it's going to shift it down 2 units. F of x equals e to the x plus 1, where the plus 1 is up there with the exponent, it's going to move it to the left 1 unit. X e to the x minus 2 is going to move it to the right 2 units, and all of that. Okay, so all those same shifts and flips and reflections and all that stuff that happened with just a regular number as opposed to e still happen. All right, any questions on that before I go on? Okay, so now we're going to go back to our regular screen. And let's see here. Okay. So now, hang on a second. All right. So there's a formula that looks like this. A equals P times E to the RT power. So the R and T are part of the exponent on the base of E. And this is a formula that represents continuous growth or continuous compounding. Where would you have that in nature? Well, okay, let's take a look at Yakima County, the population of Yakima County, all right? On January 1st, there's a certain population. Now, if you look in the newspaper, if you could look every day, you'd see that there's people in the obits, people dying, there's people being born. So just about every day, somebody's being born, somebody's dying. And over the course of the year, perhaps the population is growing, perhaps it's shrinking, but it's changing constantly, okay? So a population has continuous growth or continuous decay. When that is the case, we use this type of formula. Let's say we're dealing with money that's compounding continuously. We would use this kind of formula as opposed to that formula. So we use this formula when it compounds not continuously. So yearly, semi-annually, quarterly, whatever. We use this formula if it compounds continuously, or if it's a population that's going to grow or decay continuously. All right. So now it says the following: find A using the formula A equals P times E to the RT power, given the following values of P, R, and T. Round to the nearest hundredth. All right, let's say that P is 5,000, R is 8%, which we will convert into a decimal, and T is 20 years. Okay, so A equals 5,000 times E raised to the 0.08 times 20. Now, I can predetermine 0.08 times 20, or I can just leave it as it is. I'm going to just leave it as it is. So what I'm going to do on my calculator, I'm going to put in 5,000. Then I'm going to push the second button, and then I'm going to push the LN button, which then is going to access E to the power. And then I'm going to put in 0.08 times 20. So 0.08 times 20, close it up and push equals. And I get the following. Let's see, I get 24765.16212. And it said to round to the nearest hundredth, which would be there. So 24,765.12 would be the answer. If you have your calculator with you, I would advise you to do that to make sure that you're getting the same answer as me. If you don't, then later you can go back and look at the video and do that. But are there any?
I did.
You did, and it worked?
Yes.
Excellent. Okay, great. Any questions on that problem?
On mine, I didn't. I tried it.
Okay, okay. So are you
I have the calculator.
what's that?
I have the calculator, the same as you do.
Uh-huh. But you couldn't get the answer to be right?
No.
Okay, so clear out your calculator,
Uh-huh.
put in the number 5,000.
Mhm.
Then push the second button, which is the blue button in the upper left-hand corner.
Mhm.
Then push the button that says LN.
Mhm.
When you do that, do you see that?
Yes.
Now, put in 0.08
Mhm.
times 20,
Okay.
close up the parentheses,
Okay.
push equals.
247. Yep, I got it.
Okay, so you must have left something out, but you've got it.
Thank you. Yeah,
All right,
thank you.
excellent. Okay, let's do another one. In this case, let's see. P is 15,895. R is negative 2%, which would be negative 0.02. And T is 16 years. So A equals 15,895 times e to the negative 0.2 times 16 equals. Now, since R, the rate of growth or decay, is negative, this thing's going to decay. It's going to get smaller. So 15,895. Okay. Then the second button, then the LN button, and we should get e to the showing up. Inside that left parenthesis, we're going to go negative 0.02 times 16, close it up. So negative 0.02 times 16, close it up, push equals. And we should get 11542.13894. The 8 rounds up. So we should come up with that. So try that, make sure that's working for you. Okay with that?
Yes.
All right, super. So let's go on. Now, it says evaluate each expression without a calculator. Natural log of e to the 5th power. Okay. Keep in mind, log is log base 10. Ln is log base e. So the natural log of e to the 5th power would be log base e of e to the 5th power. So this becomes that. It's the same thing, it's just different notation. All right. Well, log base e of e to the 5th power equals some unknown quantity. But now we have a logarithmic equation. Rewriting this as an exponential equation, we get e to the box equals e to the 5th power. So the box is 5. So the natural log of e to the 5th power is 5. We okay with that?
Yes.
All right, next one. Natural log of e squared. Well, that's the same thing as log base e of e squared, which is equal to some unknown box. Changing it to an exponential equation, we get that. So the box is 2. So the natural log of e squared is 2. Well, if the natural log of e to the 5th is 5 and the natural log of e squared is 2, what do you think the natural log of e to the 7th power is?
7.
Good job. Absolutely. Okay, what about the natural log of 1 over e cubed?
-3.
Yep, good job, because that's the same thing as the natural log of e to the -3, which is log base e of e to the -3, which equals some unknown box. E to the box equals e to the -3, the box equals -3. Okay. Now let's use our calculator to find the natural log of 35.15. So we're not using the second function key. Now we're actually using the ln button. So you push the ln button and it's going to do that. Then you put in your 35.15, close it up. 35.15, close it up, equals. And 3.559624618. We're going to round to the to 4 decimal places. So right there, the 2 would round down. So 3.5596 would be the correct answer. Okay
Nice.
with that?
Yes.
All right. How about the natural log of 2.7? So put that into the calculator. Natural log of 2.7. And it comes out as 0.993251773. There's the 4 decimal places. The 5 would round up, so you'd have 0.9933. All righty. And then finally, let's do the natural log of -10. What do you get?
It says undefined.
Yeah, or domain error. Remember, you can't take the log of a negative number. Okay. So that's why that didn't work, or you said undefined. All right, just a reminder there. Okay, now we're going to use our calculator to solve the following equations. The natural log of x equals 2.6490. So basically, this is the same thing as log base e of x equals 2.6490, right? Because ln is log base e. But now we could take this logarithmic equation and rewrite it as an exponential equation, e to the 2.6490 power equals x. We can go in, and now we're going to go second ln so that we get e to the x power, or e to the, and then we're going to put in we're going to put in 2.6490. And you should get 14.1398968. Going to 4 places, we'd have the 8, the 9 in the next place would round up, so 14.1399. Getting that okay?
Yes.
Yes.
All righty. Now we're going to do some word problems using that a equals PE to the RT. And let me do this. First of all, let's put these both up here. So the first one is when interest is not compounded continuously. And the second one is when it is compounded continuously. The instructions for this problem, the title says continuous compound interest. So already it looks to me like we're looking at this one. An initial investment of $2,000. So P equals $2,000, earns 8% interest, compounded continuously. What will the investment be worth in 15 years? Okay. Now, one of the initial things is, well, but wait, we don't know what E is. Remember, E is not a variable. E is E, 2.71828, etc. Okay. So we're going to get A equals 2,000 times E to the 0.08 times 15 power. Okay. So 2,000. Then I'm going to go second ln, which gives me E to the, and then left parentheses 0.08 times 15, close right parentheses equals
Excuse me.
6640.233845. And since this is money, we would round to the nearest cent. The next column over would round down, so $6,640.23 would be the ending amount. Okay, if it was compounded continuously. And again, I use this formula, not this first one, because of the instructions continuously compounded. Okay. Any questions on that example?
No.
All right. This next problem, it says determining the previous balance. An account now contains $3,610 and has been accumulating interest at 8% annual interest, compounded continuously. How much was in the account 4 years ago? Okay, because it was compounded continuously, we're dealing with that, right?
Mhm.
But we're going backwards. It says that right now it contains this much, and the interest rate was 8%. And the time was 4 years ago. So how much was in the account 4 years ago? Okay. So we know the end game. We know this is like Jeopardy. We know the answer. We don't know the question. We know the outcome. We don't know the input. So 3610 equals PE to the 0.08 times 4. Okay. Now, I'm going to go ahead and take 0.08 times 4. 0.08 times 4, which is 0.32. And the reason for that is because for this problem, I need to solve for P. So now I'm going to divide both sides by E to the 0.32 power. So P equals 3610 divided by E to the 0.32 power. So on my calculator, 3610 divided by second ln, which gives me E to the 0.32 power, close it up, and I get 2621.398024. This was money, so I'm going to round to the nearest cent. The 8 would round up, so $2,621.40. Students often miss this problem because they don't read it carefully. They put the 3610 in for the beginning amount,
Mhm.
but it's the ending amount. Okay. Any questions about that?
No.
All right. Next problem. Bed bugs. Boy, if that doesn't make you want to crawl into bed right now. If not checked, the population of a colony of bed bugs will grow exponentially at a rate of 65% per week. If the colony currently has 50 bed bugs, how many will there be in 6 weeks? Okay. So this is a living population, so it's going to have continuous growth or continuous decay. So we're going to be using
Mhm.
this formula. Okay. Now, it's growing at a rate of 65% per week. So 0.65, I'm going to say per week. if the colony has 50 bed bug, currently has 50 bed bugs, okay? How many will there be in 6 weeks? Now, the rate is given per week, so time is in weeks, okay? Whereas in the other problems, the rate was an annual interest rate or annual growth rate, so time was in years. All right, so A equals 50 times E to the 0.65 times 6. Okay, so 50 second ln e to the 0.65 times 6 close parentheses equals, we get 2470.122455. So approximately, that's supposed to be an approximate symbol, 2,470 bed bugs.
Good.
Yeah, isn't that lovely?
Yeah.
All right, we okay with that?
Mhm.
All righty. Take a look at this problem. It says the Big Easy. I'm not sure, I guess that's a reference to New Orleans because that's where the problem takes place. It says New Orleans has steadily won back some of the population it lost in the wake of Hurricane Katrina in 2005. So during the hurricane, the population, people died, people moved away, but now it's coming back. If the current 8.2% annual increase in population remains constant, how long will it take for its population to double? All right, so we're going to use this formula because it's talking about a living, breathing population. So it's going to be growing or decaying continuously. Okay.
Mhm.
The current growth rate, so R is going to be 8.2%. So 8.2%, which is 0.082. Okay. It says, how long will it take for the population to double? So the question is the time, but there's a problem. It doesn't tell us how much the population was to start with or how much the population was to end with. It only tells us, says how long for the population to double. All right. So here's what we know. We know the starting population is P. The ending population would be double that, or 2P. So do you see how I can write those? Even though I don't know the starting population, I know that it doubles at the end.
Okay.
Now, substituting that into this formula, we get the following. 2P equals PE to the 0.082 times T power. Or we could say 2P equals P times E to the 0.082 T power. With me so far?
Mhm.
I need to solve for T, which is an exponent. But before I can do that, I need to isolate the exponential part of the problem. Well, I can get rid of P by dividing both sides by P. So 2 equals E to the 0.082 T power. Excuse me. Now, one could argue and say, well, wait a minute. What if P is 0? You can't divide by 0. Well, if P is 0, what are we even talking about? If we have a 0 population, nothing's going to happen to it, right? So it's a safe assumption that there is a positive population. Okay. All right. So 2 equals E to the 0.082 T power. Oh, this is an exponential equation. I can change it into a logarithmic equation and get the following. log base e of 2 equals 0.082 times t. Changing the exponential equation into the logarithmic equation. Okay, but log base e is natural log. So the natural log of 2 is 0.082 t. But I'm trying to solve for t. So I'm going to divide both sides by 0.082, which means t equals the natural log of 2 divided by 0.082. So there's my exact answer, but now I'm going to approximate it on the calculator. So I'm going to go natural log of 2, close it up. So ln 2 closed up, divided by 0.082. Divided by 0.082 equals, and I get 8.45301439.7. And let's see, what does the author do? It says about 8.5 years. So it rounds to the nearest 10th. So it makes it, t is approximately 8.5 years. Okay. Any questions on that? All right, let's take a look at another example. It says doubling money. We just got through doubling the population. Now we're going to double money. How long will it take $1,000 to double if it is invested at an annual rate of 5% compounded continuously? So again, we're going to use that formula. If it said compounded quarterly, we'd use the other formula. So the principal is $1,000. The annual rate is 5%, 0.05. The time is the unknown. The final amount is double the $1,000, so that would be $2,000. So how long is it going to take to turn $1,000 into $2,000 at a 5% annual rate of return when the interest is compounded continuously? Okay, so $2,000 equals $1,000 times e to the 0.05 times t. Okay, so $2,000 equals $1,000 times e, and we'll just rewrite it without the little caret. Okay, I need to isolate the exponential part of the equation. So I'm going to start out by dividing both sides by $1,000. On the left, I get what, 2. On the right, I get e to the 0.05 t. Okay.
Mm-hmm.
This is an exponential equation. We're trying to solve for the exponent, so we're going to change this into a logarithmic equation. Log base e of 2 is 0.05 times t. But log base e is natural log. So ln 2 equals 0.05 t. Divide both sides by 0.05, excuse me. So t equals the natural log of 2 over 0.05. We'll go to the calculator. Natural log of 2, close it up, divided by 0.05. And we get 13.86. So I'm going to go approximately 13.9. And this is years. Okay.
Okay.
Now, I want to point out something from the last two problems. In this problem, we were doubling the population. In this problem, we were doubling the money. Look at the number, look at the thing that we had before we punched it into the calculator. This one, we have the natural log of 2 over this number. What is that number?
The rate.
It's r, isn't it?
Yeah.
Here we have the natural log of 2. What is that number?
the rate,
R. Which brings us to a shortcut. If we're doubling a population or an amount that compounds continuously, the time is going to be equal to the natural log of 2 over the rate. So I could have done this problem by starting with the natural log of 2 over 0.082. I could have done this problem by starting with the natural log of 2 over 0.05, and I could have shortcutted all of that. But that's only when you're doubling a population or an amount that's growing continuously. So we've got that formula, we've got this formula. Okay. All righty. So for tonight, 11.5, I'll be back at 1:15 this afternoon with an office hour. Should you have any questions? Otherwise, have a great rest of the day. I'm going to stop the recording. And